In this video, we'll generate the trend line and dataset of sine and cosine using Taylor Maclaurin SERIESSUM and its own function. So we begin with the sine function. Array formula sine of the x values from 0 to 6. And the cosine. So it's array formula cosine of the x values 0 to 6. And we'll chart this. Insert chart. We use trend line. We use the scatter chart and generate a trend line. Polynomial to the 6th degree. And show the equation. And relocate it at the bottom. Here's the trend line and the trend line equation. Next, we generate the Taylor Maclaurin SERIESSUM, where we have a times x to the power n plus m. M can be a value of 0 or 1. So data validation, 0 or 1. 0 for cosine, 1 for sine. So start with cosine, that's 0. And our value for n is from 0 to infinity. So we can go as far as 12. Now we can generate the Taylor Maclaurin SERIESSUM formula, array formula, SERIESSUM of the x values. This time we'll start from m. It can be 0 or 1. And the interval or increment is 2. The coefficient will be this range. And we'll make sure that we can see this trend line of the third, the expansion. Series trend line polynomial to the 6th degree. To the 6th degree, show the equation. And our legend, there at the bottom. Now we go back to the series to change the color of the third one. We'll change that to green. You'll try the green one. And we'll make it bigger. We'll make the line thicker, like 4 or 8. Just to emphasize and show the equation. It's good. Now we continue with the coefficient. So this is equal to array formula, starting with -1. -1 is the numerator to the power n. And then we continue with the denominator. So that's divided by factorial 2 times n plus m. M, which can be 1 or 0. In this case, it's 0. So it's cosine. So the cosine, the red one, is covered by the green because the value of cosine dataset matches to the Taylor Maclaurin SERIESSUM expansion. You change that to 1, then it's the sine function. So the value of the sine function and the Taylor Maclaurin SERIESSUM expansion are the same. Next, we generate a trend line using the 1, x matrix. We use LINEST for this. So we begin with the 1, x matrix. So transpose from 0 to 6. And generate the 1, x matrix, array formula of the x values raised to the power 0 to 6. Now that we have the 1 comma x matrix, we can enter the LINEST. So LINEST data y and data x. So that's the LINEST, or these are the regression coefficients of the sine function. And for the cosine, so LINEST data y and data x. And here we have the regression coefficients of the cosine function. Now the expansion. So LINEST data y and data x. The regression coefficients of the Taylor Maclaurin SERIESSUM expansion. Now we go back for comparison. So if m equals 0, that means that the expansion is cosine. The green covers the red, and the red and the green data coefficients are the same. If we change this to 1, the green and the blue are the same. So they have the same values. So the green covers the blue sine wave. And the data set of sine is equal to, or the data set of the Taylor Maclaurin SERIESSUM expansion. This completes the use of uh, Taylor Maclaurin SERIESSUM, LINEST Polynomial Regression, and data validation to generate the trend line and trend line equations of sine